Continue with yesterday's lesson, so page 147 of your student journal. I want you to work on 9 through 10, 9 and 10, with your groupies the best you can, okay? Numbers 9 and 10 there, page 147 of the student journal. Do not get so bogged down on what you're doing yesterday. I know there will be a lot of questions, and we'll go through those, but let's work on 9 and 10 right now. Can I have your attention back up here, please? So this is kind of a picture representation of the combining of the functions. So if you're looking at number 9 here, the graphs, you have your x squared minus 4x plus 4 and your 4x minus 5. And then you're trying to figure out which one represents f plus g and which one represents f minus g. Algebraically, probably the easiest way to go about it is to do f minus g and do f plus g, and then look at the graphs. You have x squared minus 1 for f plus g. Move that over so we can see it. And then the f minus g, remember to distribute that negative. You have your x squared minus 8x plus 9. Okay. Any questions on it? Okay, next one, number 10. Doing p minus c of x. So you take your 2, you subtract and make sure that you distribute here. Distribute that negative so you get minus and minus. And then p minus c of x represents, well, that's your selling price. That's the p minus the cost to print. So when you take your selling price minus the cost to print, that's your profit for the sale of each textbook there. All right, so interpreting. Okay, questions? I want you to take out yesterday's assignment, which was page 146 of our student journal. I want you to talk to your neighbors about the problems there that we did on the bottom. So, we went through the whole top part, correct? Yesterday. The bottom part. What I want to do first is I'm going to put up the answers. And, yeah, look at that. Okay? I'm going to put up the answers. I know it's really blurry. I just wanted you to... No fun. All right. Number 5, when you multiply, you get negative 2x to the 10^3. Get all real numbers. No threats. Okay. F divided by g is negative x to the 8/3 power over 2, and domain is all real numbers. When you evaluate for x equaling negative 64 in each of those, f times g is negative 2,000 or 2,097,152, and f divided by g is negative 32,768. Now, if we just focus right there, and I really think this one becomes one of the confusing ones. A, because it's the first one. B, because it has a radical symbol in there. And then C, because we have forgotten how to deal with exponents and powers. Okay? So, I realize some of you are just copying frantically right now, but I'm gonna move it over to this page here, and I'm gonna try to show my work on a separate sheet. And really, I try to squeeze it all in on that page, but I would probably do these on a separate sheet. So if I'm taking f of g of x, multiplying them, or fg of x, what they're calling it, I like to think of it as f of x times g of x. Okay, but either way, if I am multiplying these two, I take my negative x cubed, okay, that's my f of x, and multiply that by 2 times the cubed root of x. Now I will say that I prefer changing my radicals into fractions. It makes them, I think, much easier to deal with. So rather than having 2 times the cubed root of x, I'm going to write that as 2 times x to the 1/3 power. Okay, and so what that ends up being now, if I'm looking at that, I have, I think I'm making up special symbols here. Okay, negative x cubed times 2 times x to the 1/3. Okay, now here's where the next part becomes confusing, because after you move this and you're like, well, I can't put the 2 with any of that stuff, that's fine, and you recognize that this is negative x cubed, so there's like having a negative 1 there. You're not cubing the negative, not that it would matter, but so really out front you end up with a negative 2. You kind of work from there, and then you have an x cubed times an x to the 1/3. And the common mistake that's made right there is students just go, yep, that's x to the first, and they move on with life. Okay, that's not x to the first. When you combine powers with the same base, what do you do to the powers? You add them. Okay, so this is negative 2 times x to the 3rd plus 1/3. Okay, you keep the base and you add the powers. All right, and 3 plus 1/3, I know is 3 1/3, and some of you just right there can go, okay, well, 3 1/3 is how many thirds? Oh, maybe we can't do that. 3 1/3 is how many thirds? It's 4 thirds. Okay, it's 10 thirds, not 4 thirds. Okay, it's 10 thirds. All right, that's one route to go. You could say, so if I'm just over here real quick, 3 1/3. We multiply and we add. That's 9 plus 1 is 10 over 3. Okay? That's probably the quickest way to do it. However, some of you could easily change that to a common denominator and say, well, 3 in terms of thirds, you just multiply 3 by 3, and that's how many thirds it is. That's 9 thirds. Plus 1/3 is 10 thirds. So this is negative 2 times x to the 10 thirds power. Peyton. It's just negative 1 times 2. The negative sign on the outside is not attached to the x. It's just like having a negative 1 out there. It's a good question. Any other questions there? Okay. So then becomes the domain. So when we get to here, remember this is actually, so for those of you who are like, what is that? What equals that? Remember, that's f of g of x equals that. Okay? So once we get to there, we need to find our domain. So you need to start thinking to yourself, first you could graph it and figure out your domain. Or second, you need to start thinking, when does x not exist? Like, in what situations in math have you studied where x can't be this type of number? So if we brainstorm all those situations, what are those situations where x can't be a certain thing? Yeah. Okay, so if you have an even radical, so I'll just write even here, or EV. If you have an even radical, x cannot be negative. So if I'm making my list of things x can't be, it cannot be a negative under an even radical. So do I have an even radical in this problem? No. So where we're going to start with x is we're going to start under the assumption that the domain is all real numbers until we find somewhere where it won't exist. So let's start with that. It's all real numbers until we find somewhere where it won't exist. What other situation? Yeah. You could plug it in and look at the graph and figure out your domain, unless you're not allowed to use a graphing calculator, which I know, like my daughter a lot of times this year is not allowed to use it on tests and exams. So it's important for us to be able to. So let's make this list here. What other times have we had where you're like, no, that can't be this type of number? What's that? Yeah, when x is in the denominator. Now, we haven't seen a lot of those this year, but if x is down here, x cannot be 0 in a denominator. That's bad, right? So we don't want our denominator ever to be 0. Yeah. The what?
Didn't you say when you were working
Yeah, you can't. Well, we don't want to have a square root in the denominator, but we can rationalize that. Yeah, where is it undefined? Like this is a no solution, right? This is undefined. So in a graph, these things would not show up. We wouldn't be able to find them. Okay, so for right now, that's kind of our exhaustive list. Later on, we'll hit other things, but right now, that's kind of it. So is there any point where any of these are going to change? Change our problem away from all real numbers? The answer is no, so our domain is all real numbers. Okay. The division piece, kind of the same idea. I want to walk through this one on the division as well. If I'm doing okay, that's going to be negative x to the third over 2 cubed root of x. The other thing I like to do with division problems, I like to get rid of the division symbol. So first thing I'm going to do is rewrite this. These are things that I have found much easier in math when I take and write this as that type of division problem. May not seem like a big deal right now, but the next step is rather than dividing, I actually multiply by the reciprocal, which becomes negative x cubed. And this, and actually let's change this. Let's get rid of this radical first. So what is that again? X to the 1/3. Okay, so I'm going to multiply by the reciprocal of that, which gives me 1 over 2x to the 1/3. Okay? All right. Tell your neighbor what you could do next with that. Crying's not an option. Let's assume that we've already did this. I heard someone say, let's multiply. Okay, let's assume we've got that now. Now what do you do? Okay, this is over 1. We just combine them. Yeah, could. Yeah? Are you giving me the answer? Oh, they're giving me the answer up here too. Okay, everyone tell their neighbor. You guys agree? All right, let's go with it. Emily, what do you got? Okay. Just to get it out of the denominator? Okay, let's do that a different way. I do like to get this out. Okay, yeah. So you've got a common base right here. And Sylvia, that's what you're saying, right? Okay, so we could take and you say negative, and we have our x. So I'm gonna treat this negative as a -1 so we don't confuse it as part of the x right now. Okay, and so we have 3 minus 1/3 because the base is the same. So we just subtract the 2 because we're dividing. Okay, all over 2. Okay, and so from that point, that now gives me, what's 3 minus 1/3? Okay, very good. So those of you go, well, that's 2 2/3. I hope we can do that. And then remember that's 6 7 8/3. Okay, so that's negative x to the 8/3 power over 2. Okay, looking at our there we go. Does our domain change? Oh, let me pause real quick. Rory, you have a question?
Can you make that negative 1/2 x to the 8/3?
Sure. Yeah, so write it. Are you talking about writing it as?
Yeah.
You could write it like that. If you think that's more aesthetically pleasing, word for the day, aesthetic. Yeah, pretty good. Okay, there you go. That's why some of you like comb your hair in the morning. It's more aesthetically pleasing. Then again, there's that style where some people just don't comb their hair and they think that that's fine. Who knows? All right. Good? Okay, tell your neighbor what the domain is. Ladies and gentlemen, so our domain is all real numbers. Hey, one other question that came up, and I just kind of brushed over it really quick here. The way I got from this step to that is I'm multiplying by the reciprocal. We don't divide. We multiply by the reciprocal. And if you kind of think back to like basic math you've been doing, 4 divided by 7 divided by, or 4 over 7 divided by 3 over 2, we change that to multiplication and flip that. That's all we did right here. Okay, that's all you're doing. Same skill.
Did you have to do that step in between? Like originally you had it in that format that you went to later? The negative x to the 3rd over 2x to the 1/3, that's basically what we had up there.
Right up here.
Very first thing we wrote down.
Right here?
Yeah.
Yeah, these two things. Kind of the same, yeah. Yeah, hey, good points. Sylvia's pointing out, hey, look, you almost went back to the exact same thing right there. Yeah, you're right, I did. Okay? So if you could have picked that out right away and changed that, that would have been fine as well. Yeah. Almost redundant there. Yeah.
So you know how we were like talking about a little farther down, the negative 1 times x to the 3rd, because that negative 1 isn't attached to x?
Yeah.
Is it ever attached to x? And if so, how do we know that?
It would be attached to x if the 3 was on the outside of your power. So like if you had negative x to the 3rd like that. Now with an odd power it wouldn't matter because it'd still be negative x to the 3rd when you bring it in. But if this is an even power, then that becomes positive x squared. Right? So if it's outside of the parentheses. Okay, we could still treat it as unattached and just square both parts. Okay. All right. I am not going to work through the other problems on here. However, did I give the answers? Okay. I'm going to put up the answers. I'm going to let you look at them. I'm not going to give you time. I'll read them off. I'm not going to give you time to copy them. That's not the point here. I'm hoping that I made a few things more clearer for you guys. Okay. Number 6, f times g of x, 132x to the 3/2 power, and x cannot be greater than or equal, or has to be greater than or equal to 0. Okay, and when we evaluate 4, we get 1056. Okay, notice it has to be greater than or equal to 0 because 1/2 power is the square root of. So the square root cannot be negative, therefore it has to be greater than or equal to 0. Okay, f divided by g, we get 12/11, x to the 1/2. So once again, since x to the 1/2 is a square root, it has to be greater than or equal to 0. Okay, and when we divide, we get 24/11. Number 7, and these will be available for you to look at later if you like. It's kind of messy up here, but f times g is negative x to the 11/6 power, and since that's an even root, it has to be greater than or equal to 0. And when we evaluate with 1 in there, we get negative 1. When we divide, you get negative 1 over 16x to the 7/6. That is not rationalized. I did not rationalize it there. But x is greater than or equal to 0. It's again because you have the 6th root. And when you evaluate it, you get negative 1/16. The last one, number 8. 144x to the 9/4. X has to be greater than or equal to 0. Tell your neighbor why. Okay, volunteer, why? Rory? Even root. Very good. And you get 73,728. When we divide, we get 9x to the 5/4 power. X has to be greater than or equal to 0. And you evaluate, you get 288. Okay. Questions? Guys, this is very, very mathy. I mean, there's... Hey, seriously, there's a lot of number sense there, a lot of algebra you have to do, and a lot of application of different things we've done throughout this year and previous years. And you're really dealing with a lot of just fraction work here. So when your friends that are in other classes, they're like doing their math and they're cranking all their fractions out on calculators, they really don't know how to multiply or add, tell them, I mean, it means more from you when you say, hey, look, like when you get to trig, you've got to actually be able to manipulate that by hand and quickly. I mean, look at all the fraction work you did right there, quickly. And when we actually, I mean, this is algebra 2, but when you actually get to the trig part of this course, when we're dealing with sine, cosine, tangent, secant, cosecant, cotangent, that's tons of fraction work. Okay? And you don't just use your calculator for it. Okay? Yeah? Yeah, that was a little bit of trig. Pretty tricky. Okay. Hey, I have about 4 minutes for this. I want you having your assignment by 9 or 10. So what I need you to do, this is example 5 out of your book. What I'd like you to do right now, I want you to put this into your y equals menu and this into your y equals menu. Let's call this y sub 1 and y sub 2. Okay? Since I just told you not to use your calculator, now I'm going to show you how to use your calculator. Okay? However, you won't actually be able to get the x's on there. You'll just be able to evaluate. I'll show how that may be helpful for you. Okay? Okay. There, got it. Very good. We're going to go ahead and hit quit now. Okay? So once you're in there, what we're going to do is we're going to evaluate when x equals 2. Now, guys, seriously, you should be putting these things, like I'm hoping you're keeping like a graphing calculator notebook because it will save you tons of time. And later on, when you're like, how do you do this? I'm not going to keep going through it. Okay? Write it somewhere in your notebook you can go to. Okay? But if you want to evaluate something you have in your y equals menu for a certain value of x, that's what we're doing. So we put these two things into our y equals menu, and we want to evaluate for that value of x. What we're going to do is we're going to select vars, V-A-R-S. Okay, that's this key right here. And under vars, we are going to select our y vars. We're going to go over one to the right. What type of y variable are you selecting? We are selecting a function. Where is that function? Well, where's our first one at? Y sub 1. Okay? And with that function, we are then going to... Hello? Oh, okay. We are going to add f to g, what we call g y sub 2. So we are going to add y sub 2. How do we get y sub 2? Well, we got to go back to vars, go to y vars, go to function, and go down to option 2. How many are with me? Okay, so here's the deal. Right now I've told the calculator to do is to add this thing to that thing. And the calculator says, no comprendo. It doesn't give me any x's, man. Like, that plus that does not equal that. How do I know? Because I know there's variables, man. Yeah. Okay. Yours might say, oh, you know what? I've already switched some stuff around. Hold on. I think I may have done that on here. Oh. All right. Okay, so no real answers for you? Well, mine gave me that. Oh. Just say quit. Okay? Yeah, it is go to. Okay. So what we need to do is we need to tell it to actually evaluate it when y sub 1 is equal to 2. So what we're going to do is I'm going to re-enter this, and I'm not going to go through all those keystrokes. A quick shortcut, you could either go up to that line and hit enter again, and it gives you that line again. So you can edit it. If you don't know how to do that, you could just hit second enter, and it gives you the last entry. Okay? In fact, if you keep hitting second enter, it keeps giving you more and more entries that you had before. Okay? Now, what I'm going to do is I'm going to scroll over to the plus sign, and I'm going to insert something. How do I insert something? Second delete, INS, okay? Insert. And I am going to insert parentheses, and I'm going to say, I want to evaluate y sub 1 when it equals 2. And then I'm going to go behind y sub 2, and I'm going to say, I want to evaluate that when it equals 2. And then I'm going to hit enter. Okay, you have now added those two functions. When x equals 2, you get 3.65-ish. All right? Now, I want you to do the same thing, but subtract them now. It should only take less than 30 seconds. You guys, the route you go on that, it's easier if you just go up to this line, hit enter again, and just put a minus sign right there. And then if you're going to multiply them, go up there, hit enter, and go over and hit times. And if you're going to divide them, go up there, hit enter, and go here and hit divide. How is that beneficial? Well, one way I can find it beneficial, because it doesn't actually show you what function you get when you combine them. What I could do is I could say, well, I'm going to put this in for y sub 1. You see, and a lot of you not looking right now, this is how you can check whether or not you did things right. Oh, sorry. You could put this in for y sub 1. You could put that in for y sub 2. You could put that in as the input and get an answer out. And then you can take what you actually got as your solution and input that value and see if you get the same thing. If you don't, then your simplified version is wrong, dude. Either that or you did the math wrong. You understand that? It's one way to check your work. Anyway, all right. I'm going to hand out your assignment. If you have questions, make sure you ask.